Come on, hurry up, hurry up. Hello, hello, hello. Quite a few people. So, first of all, hands up, who's tried Flutter? Yes, good, good, good. And how many of you had problems with Flutter? Okay. We need to change this. So, my name's Simon Lightfoot. I've been coding Android for 10 years, from the very beginning. And for the last 2 years, I've been primarily developing with Flutter. I do not work for Google. Just caveat right there. Anything I say is my opinion. You can get me on Twitter, and you can find some nice snippets there from Flutter. So, what is Flutter, and what is it to an Android developer? So, Flutter is a UI toolkit, primarily. So, from that perspective, it's not a framework that manages resources. It's a tool to help you build beautiful and engaging mobile apps. So it's primarily about the visuals. However, you are coding in Dart. You can do network access and other things. We'll get to that. I'm not going to talk about how to write Flutter apps. You can find plenty of content online on how to write Flutter apps. I will answer your questions at the end. So if you do have any problems with writing your Flutter app, I'll be happy to help. Flutter can be used to build new apps and enhance current ones. So there is actually an add to app feature which adds Flutter in as a module to your current project. There is a talk, I think it was last month or the month before, at droidCon New York that does cover this in in very good detail by Matt Carroll. So look that one up if you're interested about that. As I said, you do write your apps in Dart code. And this has many benefits, and one of those is that you can write your code. Dart supports JIT and AOT compilation modes. We've all had that pain with Android where you're compiling and you make a change and you have to lose your state, you have to restart your application, you have to go back through a form and fill out all the fields, and it's not very nice as a developer, especially when you spend a whole day doing it. So one of the nice features of having Dart and Flutter itself save state, and you get this kind of hot reload functionality, which really is the benefit of JIT. And then at runtime, you're getting AOT, which basically means your code is compiled to machine code. We'll go through more of that in a minute. When you do write your code, it is compiled as a standard Android project. So that does mean if you can make any modifications you like. You can add activities, fragments, all your standard Android stuff. You can still do all that. Flutter is mainly just a view that is added on top, and we'll get to how it behaves in a bit. The Flutter view itself is a surface view. It renders all the pixels. In the master branch at the moment, there is a variant which allows you to use a texture view that now enables you to have transparency. So you can imagine making an app like Google Assistant, which pops up from the bottom of the screen that has transparency onto the home screen. That will be coming out very soon. Let's carry on. Basically, in short, you can do what you want with it. So, everything you see here is shipped as part of your app. It might seem like a lot at first. The green layer is the Dart code, which is put through Dart's tree-shaking compiler. In essence, it does mean that if you're not using a whole set of fragments, a whole set of widgets, and all of this, that's not going to get included into your final product, therefore minimizing the amount of code you're actually shipping. The blue layer here is pre-compiled as libflutter. This is actually about 3.5 meg, and it means that you don't have to wait and compile C code or deal with the NDK at all, which is, I can tell you now, a benefit. And then finally, that yellow layer at the bottom, that is the Android shell. This is how the Dart runtime communicates with your app, your sort of Android side of the app. And that's just built into your classes.dex on runtime. It has minimal impact on size. I'd like to say, but when you ship in your Dart runtime, you get a new modern garbage collector. So you get that young space scavenging that we heard about, I think, last year here, and I think it came out in N. And you get that all the way back to version 16 of the API, so Android API, so that's great. That is a slide that we'll carry on with in a minute. The default activity that you get in your project, I'll tell you what, I'm going to skip back. Ignore the bullet point that's there. So this is the project view on your left there. This is where you'll find you actually, in your Flutter project, find an Android subdirectory. If you open up, you can actually open it up as a standard Android project, as I've done here. And you'll see that there's an IO Flutter plugins subpackage that is generated during build, and that contains the code that loads all of the plugins for your Flutter project. And as you can see, it's a standard Android project, so you can add your resources, you can change the launcher icon, set the window background for your launch assets and all that fun stuff. Even add SDKs, so those external SDKs from third parties, you can add them into your build.gradle. So when you first generate a Flutter project, and you open it up like this, you'll find that there's a main activity that's done for you, and extends Flutter activity, which itself is just a delegate. So it just delegates all the lifecycle events off to a separate class called the Flutter activity delegate. So you have this ability to extend any one of the activities that you already have, or implement it however you want, and you can actually implement the Flutter delegate yourself and handle the callbacks. And a good example is that down here at the bottom. That's what happens inside the delegate. It just fires it over. Nothing magical. This is inside the delegate. You don't really have to read the code here, but I'll go through some of this. So you'll see here line 145, Flutter main. That is the piece of code that starts the Dart runtime. So the Dart runtime sits in its own thread in the background. It will handle the frame events and everything else. That initializes it. So if you start your activity and your process in Android is still in the background and you return back to your app, the runtime still exists. It hasn't gone away yet, so quite handy. And then you've got the Flutter view factory, which builds the Flutter view here. And as you can see, standard stuff, builds a Flutter view, sets the layout parameters, and sets it as the content view. The view factory is there so you can override that behavior. So you can actually insert a Flutter view in any sub-view inside your Android view hierarchy if you so wish. And then finally, at the very bottom here, it finds the main app bundle and tries to run your Flutter code, your Dart code, inside the Flutter view. There's actually this link at the bottom here that will take you to the source code of the shell for Android. That'll give you all this source code, and you can go through and look at it at your leisure. A big thanks goes out actually to Matt Carroll from the Flutter team and his work improving this Android shell. Just over a year ago, this was not as good as it is now. It's very much improved. So as I was saying, Flutter ships with the Dart runtime as part of your applications. What does that actually mean? Here you'll see that in the image, you don't have to read the image, I'll explain it. This was an APK analyzer that I actually ran yesterday on just a standard demo application. It's the standard one that you build when you first create a Flutter app, the counter app. And this shows a fat APK, which basically includes ARM64 and ARM32. So it's roughly about, what, 9.7 meg? So 9.7 meg, yeah. And mainly that's this live Flutter, which is 3.5 meg for each one. So if you're going to ship this down to your clients, you obviously want to enable split APKs with ABIs. The lib Flutter, as I was saying, is the precompiled C and C++ code, sitting about 3.5 meg, which was the green section of that original diagram we looked at. Both parts of the original Dart code are now compiled into the native forms, and that is what you see as libapp.so. So that is everything that is Dart code that was in your project. That includes the code that's been made by the Flutter team itself, which is all the standard widgets and anything else that you use. And as you see, it's only 1.5 meg. The great advantage to having it this way is that you kind of get the best of both worlds. So you get that fast, reliable compilation without the need for the NDK, as I was saying. But you get that fast code as if you did compile it with C++ code with NDK. And also, you don't actually need to do split ABIs now because we have app bundle support. So It's a bonus. The second section there, assets. So a subfolder is added as part of the build process called Flutter assets. That is the assets that you describe in your pubspec YAML inside of your Flutter project. The files that the reason why they put it inside here, this was actually changed about 8 months ago, is so that plugins can now access your resources. So a good example of this, let's say we want to embed an MP4 video. You can declare that in your pubspec YAML, which is essentially like a manifest file. And that will allow the video player to play that without having to cross the boundary between Dart and the native platform. Very handy. And it generates these two files, assets manifest and font manifest. These two files are just lookup files that the framework loads, and they're used to just index and find those assets without having to search directories and so on. Also, it contains, the assets manifest contains the density versions of your images. If you're interested about how Flutter handles the densities, there is a page on the flutter.dev website which explains how you make an image subfolder with the density double. So it's like 2.0x, and that'll be your 2x version, your HDPI version, essentially. And then finally, of course, we have the standard classes.dex, and which will be any of your own Android code that you decide to put inside your project, and of course, anything in terms of platform-specific code, that shell that we were looking at. And of course, then all your Android resources as usual. I'd also like the audience to think about how much extra this is adding to your app, because it's a big question that we get asked all the time. And in truthfulness, if you're just shipping one variant of the app, it's not that much. And when you think about sort of Android X and the support libraries and all this kind of stuff, it does add up to quite a bit a lot of the time. Not having to ship that and maybe ship libflutter instead, there's a trade-off there. It's quite interesting. And since everyone keeps asking me, this is what it looks like for a debug build. I'll go through this. So this is how it differs. This is the JIT version. And as you'll see, it includes libflutter for every one of the ABIs that's supported. So that's 64-bit Intel and 32-bit Intel, and then 64-bit and 32-bit ARM. There's no AOT compiled lib app, as you can see here. So this also means that your build time on debug is, pretty quick. You're actually only Dart itself compiles to an intermediary code, and that's what is stored inside kernel.blob here. They're called Dart kernel files. If you look at the Dartlang resources on their website, you'll find more about this. It's actually an open standard, so if you want to make, there's actually room inside the way the build system works to actually put code modification and other things in the middle of the build pipeline. So you can actually do some pretty nice things by manipulating that intermediary code. There's a couple more files here, and that is the VM snapshot data and isolate snapshot data. So in Dart, as I guess some of you were saying that you're coding Flutter, so you might have used the keyword const. Const is about constructing your objects at compile time. So if you make a constant class and you declare a variable as a constant version of that variable, it will compile it will instantiate the object at compile time and then take that instantiated version and load it into memory, and that is what's shipped in these data files. So one of them is for the platform runtime, and the other one is for your app code. The VM here is actually naming holdover from when it was a VM. Now it's not. So you can ignore that. It's definitely not a VM. It's actually a runtime. And just a point here, isolate is a term given to a thread in Dart. So just in case you're wondering. And when your app starts up, Dart actually gives you a what we call main isolate, which is basically just one isolate, like your main thread on Android, which does all the most of the work and supports coroutines. There is a common question, which is how do you do threading in Dart? And you spin up other isolates, and you can cross that boundary, but the boundary between isolates is completely memory isolated. So that means if you need to call a callback, that callback has to be a global static function, essentially. You can then take some data that you got back, like an ID number, and then use that to reference and then call back into some hash map that you had in the original isolate. But this isolation really is a benefit. So I think we've all, any one of us that's been around for a while doing Android has experienced those sort of concurrency issues and issues between threads. This notion of isolating the threads is really to do with that. It really enables us to cross these boundaries and be assured that we're not going to get these deadlock situations or threading issues that we've all had before. Also, synchronization is a thing of the past. And because we have JIT mode, then this is we can hot reload in Dart, and basically these files are loaded over the wire, over the network, and then the Dart runtime is restarted. I haven't mentioned up until this point cross-platform, those horrible words that everyone hates. Hopefully you now get the picture of how it works a bit under the hood. It's not like other cross-platform products, and I want to talk about the difference. So this is the web-based approach, that phone gap on Cordova and all those fun things. Yeah, not only do we have to do with WebView, but we also have to write JavaScript. So yeah, not a fan of that one. Then of course we've got the sort of the React Native Xamarin approach, which is where we still have those native OEM widgets on the right-hand side there, but again, JavaScript, and that JavaScript code, yeah, it's compiled in JIT. Even in your release product, that's compiled in JIT. And it also means that whenever you need to rebuild the widgets or do any sort of animations, you have to cross that bridge. Cross that bridge is expensive. You can imagine it as, again, if you've got two different languages, how they talk to each other. In essence, you serialize and deserialize data into big buffers of memory. That's expensive to do at runtime. If you can just hand over memory already that the other system understands, then that would be better. This is definitely not something you want to be doing all the time. And this is the approach that Flutter takes. So this renders its output directly to the hub acceleration layer of the platform. So for example, on Android, that's probably OpenGL. It also supports Vulkan and Metal for iOS and future products which use Vulkan. And it's also doing it straight from its compiled code. Obviously, there's a benefit there, speed. You know, those frames and those frame rates that we all want to reach, those 60 FPS, now 90 FPS with Pixel 4, and we can actually achieve that with this sort of code. All the logic in your Dart application for accessing disk or network can be compiled to that native code, that machine code, and it just uses OS system calls, POSIX system calls. There's most applications now you'll find simply need to have network access and disk access, so like downloading some JSON, downloading some images, caching that to disk, using that cache when you're offline. This kind of standard behavior that we all probably have baked into most of our apps. Most of that can all be done in native machine code now. Like, you know, there's no need to really go to the platform. This bottom section, the platform channels, that again is like a bridge. That's serialization across the services. The key point here is Flutter does not implement any system-level services. So location, Bluetooth, all of this, you're never going to see that in Flutter. It's never going to have it. It's that simple. Never going to have it. It's never going to replace Android. It works on top of Android. And again, these use platform channels. Platform channels are used natively by the Flutter engine itself. They're used to communicate. A good example of this is the keyboard state. So if as you're entering text into your input field, you'll get those nice little spelling corrections and other things. All that is actually handled across this platform channel to and from the Dart runtime. And the same thing occurs with several of the other systems, which I might be able to demo later. And there's also other stuff like what we call first-party. I'll call these things down here first-party plugins. These are plugins for Flutter that are made by the Flutter team itself, and then there's also a whole range of third-party plugins made by other developers that you can also use. There's some good examples of these, certain APIs, certain SDKs that you probably already use inside your Android products. Someone's probably made a package for them already, and if they hadn't, you can now make one. So I do want to go through this. Didier Bolins, he's actually one of the common people that come to Flutter London meetup, which will be advertised at the end. Actually did this really nice graphic, and I've stolen it, shamelessly. He gave me credit. He said I can do this. This is how the Flutter engine itself does its frames and rendering its frames. It's a good time to sort of talk about a little bit about how there's a couple of misconceptions. So from an Android world, you're always taught don't nest your view hierarchy is very deep. Performance, big performance impacts. That doesn't exist in Flutter. Those things of negotiating constraints and linear layouts inside linear layouts is always a bad idea. When you get those multiple layout passes happen, they just don't happen on Flutter. The layout system is a single pass. So it goes down the tree with constraints and back up with sizes, and it's resolved in one pass. So it's also one of from an Android developer's perspective, when I first started doing Flutter, it was one of the negative points because you're not used to that layout system. And what's going to happen is you're going to get these lovely error messages, which are very constructive, saying that your constraints don't work and you've messed something up. Just be aware, they have been improving those error messages. They're definitely getting way better. And I'll be honest with you, Stack Overflow, you'll probably find a solution. If you're dealing, a little common one that's always out there, I'll give you an answer right now. If you're dealing with rows and columns and you're getting a constraint problem, wrap your child widget in an expanded. It probably will resolve your issue that you're having. Little point here to mention is this does show a full pipeline. There's not necessarily the build layout may just be a part of your layout. It doesn't necessarily mean that your entire layout is getting built again on every frame. This is just showing you what it would be for sort of a blank starting frame. We did touch on plugins already. Plugins and platform channels. It's how Dart communicates to an outside world. Because your Dart code is running in its own runtime environment, it does make it difficult. And it's the same problem that we spoke about just a little bit ago with Java and JavaScript, sorry. With it being its own complete own environment, its own language, and you've got that necessity to communicate outside, to communicate with outside resources, and you are going to get that sort of that problem of having to serialize data back and forth. Platform channels do this kind of serialization. What's pictured on the right here is just your Flutter application communicating with specific shell or host, depending on which platform you're on. This is not code you have to implement in yourself. This is done for you, but it's just an example of how a method channel communicates with the host. If you are trying to do your own plugin, all you need to implement is the method channel protocol, and there is great documentation on the flutter.dev website. So, so as I said, in short, if you're trying to deal with any host APIs, so I give this actually came up a couple of days ago. One of the community guys, Thomas, he's just got a new Samsung foldable, and he has to deal with a new foldable API. Flutter's never added that support in; it doesn't need to. So he's made his own plugin that has the callbacks and the setters and getters and so on for handling the foldable API. And this is stuff you guys can implement. As I said, because Flutter is built on top of Android, when you do your Android product, anything you can do in Android, you can still do in Flutter. These two links at the bottom. The first one is the first-party plugins. So they're both first-party plugins. One is for from the Flutter team. The other one is now Firebase. They separate them off recently. And if you want to know how to build your own plugins, take a look at these. One of the good ones is Video Player. And we all know that media on Android can be a pain. It's worth looking at this one as a good example of how you might have multiple videos working, like scrolling lists and all this kind of stuff, how you deal with that from the platform perspective. Did want to note this. So this is, it's growing fast. I mean, Flutter is ridiculously growing fast. This past year has been quite exponential, as you can see by the diagram on the right. And we're this close to catching up with React Native. Here's hoping. And as I said, if you really want to get into Flutter or trying some of this stuff out, or even trying some of that dealing with the platform itself, just try it out for an evening. Just try it out for an evening or a week or weekend sort of hacking. You'll be surprised. It's not the beast that you think it is, like the other cross-platform products. Again, open source, contribute, please. And if you're trying it for the first time, there's a command that you type, Flutter Doctor. tell you if you've got any problems with your current configuration, your environment variables, anything like that, and we'll tell you how to fix them. Resources. There's official resources at the top there. You've got the main Flutter website. It has a lot of tutorial content now. There's a lot of cookbooks and code examples. The main Flutter repository. The main Flutter organization on GitHub actually contains a separate repo for the engine. Something that actually came up yesterday in conversation was what happened to Flutter Web. Flutter Web, the repository itself is gone. It's deprecated now because it's been integrated into this repo, the Flutter one. And it also integrated into the engine product. If you want to try Flutter for Web, which is still, I believe, tech preview, then you can enable it with a Flutter. There's a command line Flutter config, and that allows you to enable Web. And then you can then, in Android Studio, see Chrome as one of the options as a device to run to, and it will launch a Chrome instance, and you can start playing around with Flutter on Web. Some of the other questions we'll cover quickly. Flutter for web, you can, any JavaScript library. Dart's always supported JS from the very beginning. It was designed as a replacement for JS, so it has JS interop. So any JavaScript stuff you've done, you can integrate that and run with that. And now they've added I think it was HTML view or something like that to the web framework. I forget the name. And that allows you to actually put web content in your web product without it going through any sort of boundaries or anything like that. Not an iframe, basically. And then finally, we've got some community stuff here. The Medium always has content coming from the community. Every other day, there's new content coming. So definitely subscribe to that if you're interested. We host, the Flutter community actually hosts a GitHub organization itself for community packages. And the main idea behind this is, at the very beginning, there's I think there still is, a small fright that one of these open source packages that you're using, the maintainer just doesn't care anymore, doesn't want to deal with it, or just becomes non-responsive, doesn't update its PRs, or even gets hit by a bus, God forgiven. So the point here is to have the organization take control of these community-led repositories. So if anything does happen, we can reassign it, we can give it to a different maintainer that wants to take over the product and carry on that maintenance of those PRs. So check it out, and if you've got any recommendations, you can actually raise issue tickets and recommend ones. And we also have our own Twitter bot, and we tweet out a lot of the Flutter events and stuff that's going on. There you go. That's the Flutter community. We were at DC Berlin a few months ago. There's a few of us there. Most of this is community people, actually. There's a few Googlers there. I want to offer this out. Flutter Europe, happening in January. If anyone doesn't know, use that promo code. The first few people to use that promo code will get 20% off, apparently. So grab that now. And then maybe we'll try a demo if this thing wants to cooperate, and I'll be happy to answer questions. There you go. That's the end.
Hello.
Hello.
So one question. As you are undoubtedly aware of, and the Android platform has a number of utilities for saving instance state, if the process should kill you.
Yeah.
And in speaking with the Flutter team, my understanding is there's not really any good support for that currently. So I'm wondering if you have any knowledge of that, happening soon, or if you have some practical tips and tricks on how to deal with that issue.
I have some very good advice. I made a package for it. I actually made a package. The problem here is that crossing that boundary between the runtime environment and the native platform environment is an asynchronous operation, whereas saving your instance state to a bundle is a synchronous operation. And you only get, even if you wait, Android will just kill your task if you take too long. Here's the thing: if you're in your app and let's say you want to keep which tab the user is on, so when they come back to the app, they're on the same tab. A really good example of that is when they change tab on that on-change event, you save that integer down to a JSON file, right? And then when your app first loads up again, you restore it from that JSON file. It sounds ridiculous, but that's what you do with like, shared preferences, and that kind of stuff. If you want to save your own state inside your application, not the view state, right? So there's no real difference. You obviously want to optimize that, so you're not writing to disk all the time, and that's what the library does. So it's called state persistence. It has a abstract storage interface. So at the moment, the one that's implemented is JSON. However, you could just implement that interface with Firebase and then have all your state or whatever state you want to store, map it off to Firebase, and then when they launch their application from a different device, you can get that state back, and it's kind of all handled for you. And that sort of it batches up the writes. So if you write to it's a kind of JSON hash map type deal. If you write to that, it will batch up those writes and store them. Because the principle here is that as your application closes, your process doesn't get closed immediately, right? So you still have threads running. You can still have threads running in the background for a period of time before Android goes, no. So you've got time to write to disk. There's no big problem there at all. Does that help? Okay, cool.
Hi. Do you have support for desktop as well?
It's actually being worked on at the moment. So you can, with that same Flutter config, you can enable desktop support. Mac OS X is currently the forerunner of desktop support. That's what they've been working on the past, I think, 4 to 6 months or something. They've been working currently on Linux to map with the Mac stuff, and then working on a new plugin architecture so that you can cross the desktop products, web and mobile with one sort of API. We're actually getting an update to the pub specs so you know on the pub website if it supports desktop or if it supports different platforms. You can enable it, you can use it, but the problem you've got is if you want to do anything in terms of communications to the outside world, plugin support, you can still do that. You still have platform channels, but then you have to implement that yourself, just like a plugin.
And what about Windows as well?
Sorry. Windows is on the bottom of the list, I'm afraid. I actually use Windows, and I actually made a version of a desktop product with Flutter that uses Windows. The point here is you don't want to release sort of an alpha thing and have people start using it. You want to sort of stabilize that API. It just so happens that Windows, with its new UWP and dealing with DirectX, it's all a big fun mess.
Well, we don't use Windows, but our customers do, unfortunately.
Yeah, it's coming. It'll be basically once they finish the Mac and Linux, you'll see Windows come soon after.
Cool, thanks.
They're making you run for it.
Is there support for widget remote views in Android?
So say again?
Remote views in a widget?
Yeah.
Does Flutter support it?
Okay, so there's a repository that I need to publish that has some code for that. I did a talk at Flutter London, actually doing desktop, home screen widgets with Flutter. It doesn't support remote views in the way that you expect because obviously it renders itself, all the pixels. But what you can do, which is the trick I think many Android apps have done when they want custom UI in their desktop widgets, is just to render it and send a bitmap. So a lot of the time, what you can actually do at the moment is have a remote view, which is an image view, and then just in your dark code, you're rendering that widget, and you just send the image over to the platform to be displayed on the home screen, for instance.
Okay, another question quickly. How does Flutter compare with some of the newer frameworks like Jetpack, Compose? I mean, what's your... Just
I was waiting for that
very
question.
briefly, please, if you would like to share your thoughts. Thank you.
So I've not used Jetpack Compose, so I couldn't speak to it, to be honest. From what I understand, it's just a set of classes that render to canvas, which is very similar to what Flutter does. However, it still doesn't compile down to machine code. So you get that reactive UI benefit, but you're still not getting the other benefits you're going to get from writing in Flutter, for instance, and cross-platform, right? So, cool. Hey.
Hi. I've been using Flutter, but just for experimental. I found it's quite easy for building the UI. But my question is, do you think it's a good idea just I use Flutter for the UI, then I use the native code, for example, Java or Kotlin, for the fundamental lower level
business
controls?
logic.
Yeah.
I don't think it really matters. It would depend really on the amount of calls that you're making. I mean, put it this way, if you're making one of these calls to the native platform on every frame, 10 on every frame, that's a lot of overhead you're adding. If you need to react on a frame-by-frame basis, as you do now to not have frame stutter and jank, then probably not a good idea. It's possible though. To be honest, I've never found a problem. I mean, to begin with, I do admit, when I was coming from Android to Flutter, there's obviously teething problems. It's like when you get any new operating system, you need to learn the new things or new gestures or whatever it might be. And in doing so, you eventually go, oh no, this is the latest and greatest thing. I like this, and I didn't like that. Why did I ever like this old thing that, So I kind of feel that from my perspective, I made this, once I got past those hurdles, I started writing all my back-end code, all my business logic and tests and everything in Dart code. Another advantage, of course, is Dart. You can run it on the server. So those models, you can make a models package and then have that between your server code and your iOS code and your Android code. So there is an advantage to putting your business logic in Dart and not using the platform.
Thank you.
Hi.
Hi.
What sort of architectural patterns would you recommend for best decoupling sort of UI and business logic?
Best patterns. I mean, it's just a matter of opinion, really. Choose your poison. It supports Redux, right? There's Flutter Redux. You can use that. If your current Android product uses Redux and you want to make a new version of the product, well, continue using Redux. You can name the classes the same thing. You can same actions, same reducers. Personally, I just use the same sort of repository pattern that most people use. You have your services, you have a repository layer, you have your front-end UI, you separate your concerns. It works fine for me. There's quite a few people that are interested in block as a pattern at the moment, which use streams mainly for input and output to your sort of business logic. Personally, I find just calling a function perfectly fine. And if it needs to do asynchronous work, it will go off and do asynchronous work. So it's not really a problem.
Okay, cool, thanks.
Hi. When I last checked DartPub, I saw that when I see the plugins which are targeting Flutter or which are compatible with Flutter, they are mostly compatible only with Android and iOS and not with the web as a target. Who is going to enforce this, that if I look for an audio plugin to play audio files, then...
On what, sorry, which platform were you saying?
If I want to target Android, iOS, and web from Flutter.
Right. Web is still tech preview. And because it's still tech preview, there isn't a stable plugin API yet. That's what they're currently working on. And once it's stable, then there'll be a push to get a lot of the primary package authors supporting web in their products. And there already is quite a few that are using the current JS interop and HTML view and some of these other things to give themselves that interop capability. But someone asked the other day, how would they make a product that does, I think, video calling with Flutter? That's perfectly viable. You have a video player and everything else. But of course, video player itself doesn't support web. But what it does have is a contract, that method channel that it's using. So what they actually went ahead and did a JS version of that contract, and it uses, there's a new, what's it called? There's a new, I think it's calling API, I can't remember what it's called now, on web. It escapes me right now. But they use that new video and phone call sort of, what's it called? Doesn't matter, anyway. That's it, RTC, yeah, WebRTC. They actually implemented that, and they were able to do video playback and then did an audio one as well to handle audio. The hope is that, obviously these things are for startups, that is their IP, and they don't necessarily want to publish that stuff, but the hope is that if people are doing Flutter code in their spare time, then we'll start seeing more and more of that in the open source community.
Thank you.
Any other question?
Hi. So my question is, how did you introduce it in your company. So do you have already
I'm
a
the
product?
CTO, so I get to make the decision. I personally just said it's too expensive to use iOS contractors, so we're going to use Flutter. But over the last year, a lot of people have been coming and asking that sort of question about how do you introduce into your company. The advice that I've kind of settled on at the moment is do an example. So if you've got a current product that's an Android iOS app, and you want to convince them to try Flutter out, replicate like the first section or the first screen, the first tab in Flutter, and say, look, time yourself. How many hours did you spend working on this? And say, look, I did that in 2 days or a week or something, and it took us 6 months to do the same thing previously. Maybe there's a reason why we should try this out, because it'd be a lot quicker, a lot faster, and we can get our features out the door with animations. Yeah, cool.
Thanks.
Okay. Oh.
Talking cross-platform, basically, would you rather just use the material one for iOS and Android, or do you end up building the UI twice with the Cupertino and the material ones?
I'll be honest, I've not built an app with the Cupertino stuff. I've used them as in my own, playing around with them, but I've never actually produced a commercial product with the Cupertino stuff. Not for want of trying, but most products actually end up with their own design language, right? So it'll be mainly sort of material design-esque, but then there'll be certain things that they want, like certain round corners or panels or such and such, which is very much their design language for their product. And that's what you end up implementing. The material design, so you have a certain set of widgets in Flutter which are material design, right? A good example of that is Inkwell. Inkwell is a pretty basic one. It does touch input and has that splash ripple on the parent material widget. People are like, how do I do touch? How do I handle my own button? Well, you make a stateful widget. You have a gesture detector on tap down, on tap up, or whatever it might be, and you can do your own, change the color, and then do a nice scaling effect, dazzle the user. So in the end, you end up doing something that's quite specific for that product, and normally based off of material stuff, but there's no limitation. Okay. Does that kind of help? Yeah. I mean, would say at this point, for instance, if you're doing that, you want the share icon, for example, to be the iOS share icon, right? Even if it's material design looking, you want that icon to be the one from iOS, or the one from Android, depending on what platform they're on. And you can do that with Flutter. So you can look at the current theme and detect the target platform and see if that is equal to Android or Future or whatever it might be, iOS, and change that icon depending on that state.
Okay, so I'd rather have the same thing goes probably for bottom sheets and dialogues and stuff like that.
Yeah, so in fact,
thing where people would expect the native behavior, basically.
Pretty much every one of the Flutter apps I've worked on has had this sort of platform dialogue idea where you give the title of the content, the actions, and then it will display an alert dialogue for Android and a Cupertino dialogue for iOS. Okay, so you get the nice red and blue buttons and so on.
Cool, thanks.
Cool. All right then. Thank you very much.